coming conferences, there's PyBay in August, right? Which you should go register for if your company is interested in sponsoring. They've got $2,500, $5,000 sponsorships, very affordable. Get your logo on a T-shirt, for the low price of $2,500. Let's see. Any other announcements before we get started? Okay, great. So without further ado, all right, Adam. There he is.
I'm not talking to this, right? Can you hear me well in the back?
We can hear you for the recording.
Ooh, I'm on record. All right. So hi, everyone. My name is Adam. I didn't put it on the first slide. A good tip. I'm going to talk today about using machine learning in production. This is a 15-minute talk, so I'm obviously just scratching the surface, but I try to kind of give you a mix of the broad strokes as well as some actionable tips that will get you started if this is something you need to deal with. So as a brief overview, I'm going to talk about how do you go about doing rapid prototyping. That's usually the first step where you just have some data you want to try and do something interesting with. And then I'll talk a little bit about managing training workflow and model lifecycle in production. And this is more about how do you actually go about integrating the flow of training a model and using it as part of your product. And then finally, I'll just say, I'll kind of summarize and touch a little bit about what do you do when you scale up, once you start actually becoming a larger organization. Few disclaimers just to kind of lay the lay of the land. I'm not going to talk about all, how to solve artificial general intelligence. Most of the tutorials online are about actual techniques for applying on certain problems. This talk is more focused about how to actually architect the solutions and move them to production. And specifically, I'm very biased towards text and NLP applications, as well as using AWS. AWS are pretty much at the forefront. A lot of what I say will probably be applicable to other cloud providers, but as of things stand right now, they still seem to be ahead of the pack. So first topic, rapid prototyping. The answer here is pretty straightforward. Use Jupyter notebooks. I don't know if anyone here doesn't know about Jupyter notebooks by now. They're great. I'm going to show a few slides kind of demonstrating what they can do, but long story short, you can manage them the same way you would code. You can check them into your repository. GitHub has a very nice display for them. You can then incorporate markdown, visualizations, and interactive widgets. So they make for a very rich kind of way that you can then publish on your website, for example, if you're making a tutorial or a presentation. And then as of 2017, AWS came out with this product called SageMaker, which makes it really easy to get a notebook server running on a provisioned infrastructure that AWS runs for you. So you don't even have to worry about setting up an EC2 machine, security policies, stuff like that. With a click of a button, you can have a Python notebook running on a very powerful machine. I'll just kind of try and give you a little bit of some of the things you can do. So here I'm basically loading a Pandas data frame. Pandas is a very popular framework for you working with basically data tables. That's an easy way to think about it. So as you can see out of the box, there's a very nice integration, very nice display of Pandas data frames in notebooks. This is very useful if you want to kind of summarize data sets or just kind of do selects and see the results in line. Visualizations are great. Matplotlib has kind of been the legacy framework, but nowadays there are frameworks like Seaborn that kind of build on top of it and lets you get pretty much publication-grade visualizations very easily. Timing and profiling. So there's a bunch of these magic commands. If you're familiar with IPython, same thing. Here I'm showing basically an extension that lets you do a line profiling. So again, with one button, pretty much you can get line-by-line profiling for your function. This is definitely useful once you start prototyping machine learning models. Maybe your algorithm hits a snag and it's getting a little slow. This saves you a lot of time. And then finally, it's extendable. So there are notebook extensions. Here, this is, I believe this is a screen that shows one in particular called NB extensions that has a very rich ecosystem of kind of small plugins that you can manage via UI, things like code folding, but then also more interesting things like doing a PEP8 or FLEC8 kind of linking on your code. So that's very cool too. And then a couple of words about SageMaker. I mentioned it. I'm not trying to advertise AWS here, but we do use it and it's been pretty great for us. So long story short, you open your AWS console or via an API call, of course. You can create a notebook instance. once you create it, you basically choose a machine instance type you want. So, you can get into a multi-core processing very easily. And then you can start and stop it. So you don't have to pay for the notebook running all the time. You can basically set it up, run some computations, pause it, restart it again when you want to resume. You can obviously collaborate this way pretty easily. So this is a great way to get started. And I'll get back to SageMaker a little later. That's just one more kind of example of what you can do with SageMaker. They also let you define this lifecycle configuration, which basically lets you bootstrap your notebook so that you can install various OS dependencies, which in machine learning applications actually comes up a lot. So that was just obviously a kind of, just the surface of how you can do prototyping with Jupyter. I'll talk a little bit about now how do you actually manage training and running your models in production. So first of all, if some of you have never looked at machine learning or had to deal with it, usually the workflow is around doing some kind of data exploration, playing around with it, then figuring out some business problem. Maybe you want to be able to predict something based on text or do sentiment analysis. And then once you identify that, you come up with a model, you train it on a data set, on a labeled data set, and then once you have a trained model, you can put it behind an API and serve it. So you can query it with text, get back a prediction. That's kind of the big picture. So this is kind of, I tried to create a few simple recipes. I'll go through them pretty quickly, but the main takeaway, if nothing else, is when you're just getting started, don't worry too much about workflow and lifecycle. Honestly, it becomes a problem only when your organization grows or your product becomes more mature, you have more data, and then you start caring about all the things you care about with engineering best practices anyway, like modularity, interfaces, versioning, collaboration, and so forth. And I tried to kind of lay down a few simple recipes to kind of show you how you can grow with your organization. So recipe number 0, it's anything goes. So here, basically, this is kind of the simplest thing you can do. Let's say you train the model, and it's literally a very small file, serialized, maybe less than 100 megabytes. So my advice to you would be, don't do anything special. Just literally put it into your code repository, even though it's an artifact and they tell you not to do it. You can use Gitflow to manage your service versioning and release workflow. Gitflow is a great kind of repository workflow tool regardless. I'll show a quick slide on that. And then basically your model lifecycle just follows your service. So let's say you have one microservice that serves an API for doing some kind of classification. You put your model file, which might be 50 megabytes inside that service. You can update your manifest.in, for example, to let your Python package bundle that up for you. And then you pretty much just retrain your model offline whenever you want to. There's a small variant here where you can actually store the serialized model on S3 and fetch it when you start your service, and then only store kind of the URI in your service. That's fine too. This will get you very far. So you don't really need to worry about anything more complex, when you're just getting started. A very, quick side note about Gitflow. Basically, it's a branching methodology. If you've never used it, we use it here at Globality very successfully. The idea is that you have a develop branch, you create tagged versions where you push things to master, and you use these feature branches to kind of branch off and create these branches. This is great for code, you can do code reviews via pull request. It works well for serializing models as well. So kind of next up in the complexity chain, and this is a few reasons why you might need to go this way. So maybe at this point, suddenly you have some library code that now needs to be shared between a few different models or different kind of services and training modules. Maybe you have more collaborators. Maybe you need to try out different models and be able to swap them in and out pretty quickly. So we came up with this very simple kind of architecture. So these are all Python packages. You end up having one package repository of commons. This is just common library code that's used by both your training as well as your actual service. You have a training repository. This, for example, can hold your notebooks and the other code that's only used for training. You have a data repository where, here again, you just literally serialize your trained model. The next thing is you just get versioning and all the kind of CI-based deployment you would get of managing your code using these kind of tools anyway. And finally, you have the service, which basically depends on the commons library and your data package. And then side by side with that, you start thinking more about interfaces. So abstract base classes and APIs. I'll kind of skim through this because I'm running short of time, but Scikit-learn, great framework in Python. Pretty much most of the other major machine learning frameworks in Python adopted their interface, so most of them support it. So TensorFlow, XGBoost, which is a competition-winning machine learning framework, Dask, they all support scikit-learn interfaces. And I'll kind of give you a very quick idea of what this actually means in practice. They basically tell you that your constructor should do nothing except assignments so that it can be easily serializable. They have a fit function. Once you fit something, this basically means you're creating some learned parameters. Those parameters have a convention where they're followed by an underscore, so it's easy to tell a trained parameter from kind of a parameter you pass into the algorithm. And then finally, they have a predict function. You follow these guidelines, and you can now basically mix and match your code with a lot of sklearn code, and that's a very big ecosystem. And one side benefit is that you can even go further and modularize your code so that now you have your own open source libraries that you wrote that are sklearn based, and now you get all the benefits of the open source community, obviously. So maybe some other people, somewhere else in the world find your code useful, they want to collaborate, so you get that, and then of course it makes it easy to share code between different components. This is just an extension of my previous example where you have a couple of services that have a lot of overlap, so you can kind of modularize that and have this code sharing done between those open source libraries. Couple of variants, I'll skim through this, I'll share the slides later, but if your model grows and you still want to use Git to store it, there's actually solutions for that too. There's Git LFS, which is not very well known, I think, but basically it amounts to storing a pointer to large files on Git so that checking code in and out is very quick, and then if you really want to fetch the entire package, you can do that separately. And then there are kind of custom-tailored solutions. TensorFlow serving is one, where TensorFlow, which is obviously a very well-known machine learning framework, basically has its own server for running machine learning models. I'll skim through this. This is just a Git LFS architecture and TensorFlow examples. And then I'll give you kind of the final recipe, and this is more like where it seems like the industry is going. So we're not there yet, definitely, but all the indications seem to suggest that this is how people are going to build applications a year from now. So the idea is that you go completely serverless. Amazon SageMaker basically is oriented for that. So SageMaker, in a nutshell, is comprised of letting you run notebooks in the cloud for prototyping, then lets you basically train algorithms on their infrastructure. You can choose one of well-known kind of algorithms out of the box, or you can wrap your own algorithm in a Docker container, ship it there, and they will run it for you. And then finally, you can actually serve your model using their inference API. So you just need to make sure your Docker container bundles an API that adheres to some spec, and they will run that on their infrastructure, take care of scaling and everything for you. And then obviously you get all the nice monitoring and stuff like that. And then there's some nice interesting things you can start doing with more recent frameworks like Chalice and serverless. This basically will let you retrain your model. So for example, you can set up an Amazon Lambda function to very easily either on demand or on a kind of a schedule retrain your models. This is just an example of how easy it is to literally just tell it you want to start a training job. You just specify your image. This is something that will be on Amazon's Elastic Docker registry, and you're done. There's a couple of examples on how you would go about writing a Chalice, basically API definition. You write this little piece of code, you click Chalice deploy, and a second later you have a running API endpoint. That's pretty cool. And then finally, I'll just kind of try and give you a few takeaways on how to scale up. And again, don't rush to any of this stuff. This is generally applicable if you have more training data, bigger trained models, or just more moving parts. So more developers or more product features that you're now supporting. For more training data, first of all, congratulations. This is a great problem to have. The kind of the main things that change here are that you start to care more about distributed computation and storage. Usually you get to a point where you have a lot of more kind of complicated data pre-processing pipelines. A few companies, and I think it's pretty telling that these are big established companies that had to tackle this problem, but Airbnb, Spotify, and LinkedIn came up with these kind of workflow management frameworks. These essentially let you define a directed acyclic graph of tasks that typically have to do with moving data around and transforming it in various ways. So you can kind of do that offline and have great provisioning for that. And then you can still use Amazon SageMaker notebooks, for example, backed by something like Dask or Spark, so that now you're still using notebooks as the front end, but you're offloading heavy computation to a cluster of machines using one of these frameworks. I won't go into details about them, but I put some references to tutorials about them. Dask is pretty great. We started using it recently. And then finally, you start caring about performance. So you might start really profiling and using some frameworks such as Numba or Numba and Cython. So this can really squeeze more performance out of your code. I'll give a couple of quick examples. These are just some of these workflow management tools. They're kind of all really about the same thing, roughly speaking. But then a couple of examples for using Dask. This is actually something I recently learned. So let's say you want to transform a pandas data frame. You typically have a function you call apply with, and this applies it row by row, but it's single call. So basically you can transform it into the Dask framework's version of a data frame, and with basically 2 lines, have it applied using all the cores you have, basically. So if you combine it with running a notebook on SageMaker instance with 10 cores, for example, this can save you lots of time while prototyping if you need to rerun certain computations. And then one quick word about Numba. I don't know if any of you had to kind of mess around with NumPy, but sometimes when your algorithm involves some kind of numerical computation where you have various arrays, you do things like arithmetic operations on them. Long story short, with Numba, you add in this little decorator, and you pretty much, in a lot of cases where your function really is mostly about array manipulation, you can get those kind of savings in the computation. This is actually taken from a blog post I found that combines Numba and Dask, which is pretty great. So you get both parallelization into multiple cores or machines, as well as savings per machine. So this might take you very far. You might think that you need to set up this crazy cluster of machines, but you might find out that with one very strong multi-core machine and some of these tricks, you don't really need to jump there that quickly. I can't have a talk about machine learning without mentioning deep learning. So I'll just kind of quickly say TensorFlow and MXNet are both natively supported in SageMaker. So if you're creating your models there, that makes it very easy. But having said that, there is an emerging industry standard for persisting these trained models and basically for framework interoperability. This is called ONNX. It's backed by all the big players, Facebook, Microsoft, you choose. And this basically lets you train with one framework and then run with another. So some frameworks are easier for training, some are more efficient for serving queries. And then another interesting property is that it now kind of opens a marketplace of models. So you can go up there, see other people's trained models, very easily load them up and try them out. So this seems like another big trend in the industry. And then finally, bigger trained models. Main takeaways is you offload your trained model storage to a dedicated medium, such as Git LFS, S3, or SageMaker. You offload the model serving to a dedicated service. This could be your own microservice, or when it gets harder and harder, you can use something like SageMaker's APIs or TensorFlow serving. And then you start worrying about things that you do anyway when your application gets a lot of traffic. So cache warming, monitoring, stuff like that. And well, I guess this is kind of the final piece of, you have more moving parts, more people in the organization, more processes, more features. So here really the best tip I can give you is just software engineering best practices apply. Separate your functionality. If you're trying to if you have 3 models doing 3 things, just separate them out into their own services. It'll make everything much more manageable. Manage the code as you would any other code project. You can use Gitflow or any other kind of branching methodology you like, code reviews. Use standard interfaces. So we kind of take it for granted, but try and use, abstract base classes of ideally something like scikit-learn that you can easily swap in and out, ONNX, as I just mentioned, RESTful APIs, obviously. And then as code is productionalized, coding standards, so linting and unit test, prototype code tends to be very messy. People are in a hurry. Once you actually start using it in production, you want people to be able to get in and read it and kind of test it and make sure that things are reproducible. And then finally, analytics and monitoring. If nothing else, just make sure you track in your analytics backend whenever you push the model version update, so you can correlate that something happened, suddenly your traffic dropped or increased with deploy that you did. If you do nothing else, do that in analytics. That's it. Any questions or comments? I'm happy to take them now or via email. Yeah.
So with Jupyter Notebooks, what I find is you make one little change, and now the notebook's changed. And if you try to do a git diff, it shows you all this junk.
Right.
So what do you do about that?
A couple of thoughts. So first of all, one approach is to basically, before you save, you have this really handy function of saying clear restart kernel and clear all outputs, which basically just removes all the output and only saves the self. And you can combine it with another trick that a lot of people do, which is set up a Git hook that renders HTML of the notebook when you commit. So you kind of get the best of both worlds. Your notebook remains only the code without all these artifacts that keep changing, but you also have a snapshot of the actual output so you can kind of review it, for example, as part of the commit. So that's kind of one solution. For us, honestly, what I've tried to do is just keep the notebooks pretty small. So if you have a very long workflow, I would have a few notebooks, one after the other. And then if there's a change in one, even if there's still output kind of mixed in there, still pretty easy to tell in a pull request what changed.
More questions? I was kind of curious.
Yeah.
How does Globality use machine
Yep.
learning?
So great question. So 3 places. One of them is kind of on the user-facing side. Basically, our platform is about a marketplace for businesses, for clients and service providers to create projects together. So one of the first things we ask for a client is a project description. This is given to us in free-form text. We then apply a fairly standard NLP pipeline on that, named entity recognition, a relation extraction, to try and kind of already piece together a pretty good idea of which services are required, in which industry, geography, where is this project taking place. This kind of lets us really quickly hone down on the smallest pool of candidate service providers that we should now kind of figure out how we want to match. The matching algorithm itself, obviously, that's another big one. So we have a series of follow-up questions that we ask the client user after they give us their project description, and then we kind of have this structured representation of a project. This is kind of your query, and you're now querying that against your catalog of service providers, so you can think of it as kind of a ranking or scoring problem. So obviously, a lot goes into tuning that algorithm as well. And then finally, I would say that kind of on the service provider side, we do a lot of things around proactively scraping content. So for example, we want to enlarge our service provider network as much as possible without having to ask for service provider companies to onboard our platform, give us the information themselves before they actually have a project opportunity, and then they're happy to do it. So to do that, we kind of write our own scraping modules, I would say. We actually run them on Scraping Hub. If anyone ever used that, that's been pretty good for us. But then we have some machine learning in the mix there to try and kind of predict which areas of a web page are, for example, a case study or an about us or a biography of one of the team leads. This makes it very useful for us because we can then index those, and then it makes it very easy to surface those providers using search when we have a new project. So I would say those are the main areas right now. Cool. I put a bunch of references in here because I just couldn't really deep dive into any one thing. All the frameworks I mentioned, some tutorials that I found pretty useful. I'll find a way to share the slide if anyone's interested, and hope you find it useful.